In this class, we discuss the Cauchy's criterion of convergence of improper integration. Okay, and the Cauchy's criterion is the necessary and sufficient condition of convergence of improper integration. Right? And what is the Cauchy's criterion of convergence? This gives integration a to b fx dx, where fx have a point of infinite discontinuity at x equal to a, that is at the lower limit or lower range of the integration, and is convergent if for any given epsilon dash greater than 0 there exists delta greater than 0, and delta is such that delta this is equal to delta of epsilon dash, that is delta depend upon epsilon dash only. Okay, such that mod of integration a plus epsilon 1 to to a plus epsilon 2 fx dx less than epsilon dash for 0 less than epsilon 1 less than epsilon 2 less than delta. This is the Cauchy's criterion of convergence of the improper integration. Now we try to prove this Cauchy's criterion. Okay, and to prove this theorem, we first let phi of x, this is not phi of x, this is phi of epsilon, because we let phi of epsilon, this is equal to a plus epsilon to b fx dx, and since the function fx has infinite discontinuity at the point a, so we choose an epsilon greater than 0 such that 0 less than epsilon less than b minus a, and integration a plus epsilon to b fx dx. So this function fx have no infinite discontinuity in the range a plus epsilon to b, because we delete the infinite discontinuity at the point a. Right? Now if we try to find the limit epsilon tends to 0 plus phi of epsilon, okay, phi of epsilon, to exist this limit, the Cauchy's criterion of limit says that the necessary and sufficient condition that this limit exists finitely is that, right? So we write here the necessary and sufficient condition that limit epsilon tends to 0 plus phi of epsilon exists finitely is that there exists epsilon dash greater than 0, or is that for any epsilon dash greater than 0 there exists delta, this is equal to delta of epsilon dash greater than 0 such that mod of phi of epsilon 1 minus phi of epsilon 2 less than epsilon dash, where 0 less than epsilon 1 less than epsilon 2 less than delta. Okay, this is the Cauchy's criterion of limit or existence of limit. Now we put the value of phi of epsilon 1 and phi of epsilon 2 from this relation, and we get mod of integration a plus epsilon 1 to b fx dx minus integration a plus epsilon 2 to b fx dx less than epsilon dash, where this is the same Okay, now here we get three terms, a plus epsilon 1, a plus epsilon 2 and t, and we draw a real line, and this is 0, and if we take a plus epsilon 1 here, a plus epsilon 1, then we must have a plus epsilon 2 to the right side of this point, a plus epsilon 2, because it is given that epsilon 1 less than epsilon 2, and this is big obviously. Okay, so we get here a plus epsilon 2 to b. So we first the integration from this point to this point and subtract this integration. So we subtract from this point to this point. So we get the subtraction is given by integration mod of integration a plus epsilon 1 to a plus epsilon 2 fx dx less than epsilon dash, where delta or where 0 less than epsilon 1 less than epsilon 2 less than delta, and delta this is equal to delta of epsilon dash. Okay, and we see that this is our Cauchy's criterion of convergence or the condition of convergence of improper integration. Okay, so this is very simple proof, and this is the complete proof of this theorem. Right? Thank you for watching.